Really? Is another westerly wind burst forecast? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 25th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Mont the Drifter, Tim Caston, Barry Hill, Clay Goose, Peter Carpenter, Follow and Believe, Tyler Schmidt, E. Slate, BC Hall, Evolution Moto, and the big contributor for the week, Mark Denzer. Thank you all so much. I really appreciate it. And with that, let's get to work. We're going to start by looking at significant wave heights around the planet. Starting in the North Pacific, we do have a gale with 5-foot seas on the date line, more or less. Aim pretty well to the southeast. This is part of a developing new system, mainly targeting California. Yet another gale is behind that off Japan, again with 23-foot seas or so, that pushing off to the west. Both these to evolve and produce meaningful swell for the Hawaiian Islands and California. Hooray! In the South Pacific, pretty quiet pattern, a little area of 21-foot seas, but nothing really significant happening there. Obviously, though, the biggest activity is in the North Atlantic, a broad gale here, only 30-foot seas or so, actually 32-foot seas. These are the highest seas over this entire domain, targeting Europe, Portugal, down into Morocco, and expected to build from there. South Atlantic, quiet pattern, and in the Indian Ocean, a gale fading with 20-foot seas, but it was stronger, pushing well off to the northeast, targeting Western Australia up into Indonesia and the Mentawai Islands. But before we get into all that, let's check current conditions. We're going to start up in the Pacific Northwest at looking at the buoys. Grays Harbor buoy number 036 there off the intersection of or the border between the Oregon and Washington. We're looking at all the energy that's hitting that buoy, not a whole lot, all the way up from 33.3 second. That'd be long, energetic swell, the whole way down to 5-second period. That'd be like almost unrideable wind swell. We see a little bump here in the 16, 17, 18 second period range. What is it, like 0.9 of a foot? It's not exact. The swell is not defined by one frequency band, but also the frequency bands on the shoulder of the peak, or where the peak energy is. So some swell there, and you see then a mixture of other swells, wind swell, and other background swell in the 0.7 of a foot range on down. Put that all together, primary swell, 1.3 feet at 17.3 seconds from 271 degrees or 73 degrees, making surf theoretically at 2.3 feet at a normal standard beach break, no swell enhancing bathymetry. With secondary swell, 2 feet at 10 seconds from 263 degrees, also putting about 2 foot of energy into the mix. Heading down to Northern California, the San Francisco buoy, 46026, really the north end of Central California. The Golden Gate kind of like is the dividing line. And we see, again, a little hint of that longer period energy, but mostly in the, somewhere split between 14.7 down to about 11.4 seconds. This is all swell that's been radiating from a series of gales, primarily affecting Hawaii, with little bits of energy eventually reaching it into the California coast. Primary swell 2.3 feet at 12.8 seconds from 261 degrees, making surf 2.9 feet, though there were waves that were head high or maybe even a bit bigger at select spots today. Secondary swell 0.9 feet at 17.5 seconds from, says 116 degrees, but I believe it's more from the northwest, making surf at about 1.5 feet. And then over to Southern California, or down to Southern California, the Point Loma South buoy, 191 there off of San Diego. A little bit more of energy here concentrated in the 14.3 second period band, with much less of that background energy in the mix and none of the longer period swell really showing up yet. Primary swell 2.5 feet at 13.8 seconds from 258 degrees, making surf at 3.4 feet. And yeah, there were chest-high waves at select spots this morning. Secondary swell 1.3 feet at 10.4 seconds from 258 degrees and making basically unrideable additional energy. And the final stop on the tour, over to the north shore of Oahu, a much more muted pattern. This is sort of the calm before the storm, if you will. Hitting here first, that will eventually work, that calmness will eventually work its way into California. But you see a little bit of energy at 14 seconds and some wind swell in the mix. Nothing significant. Primary swell 1.5 feet at 13.6 seconds from 319 degrees, making surf 2 foot. Yeah, 2 foot Hawaiian. It was head high this morning at good spots. And secondary swell 2 feet at 10 seconds from 352 degrees, also at about 2 feet. So all in all, looking at our primary forecast locations, a pretty relaxed, calm sea state is, for the moment, in effect. So what has been going on in our planet's oceans for the past week? We're going to go back to last week, Saturday, the 17th of January, 12Z run of the model. Just sort of take a look at the wave models. Yeah, a series of gales here developed over the dateline. Nothing particularly powerful. This one here moving into Sunday had like 28 foot, 28.6 foot seas briefly. Another one formed behind that with 26-foot seas and then rotating off to the northeast. I think it produced, there you go, 31-foot seas for a moment there on Tuesday. You see the swell fronts from those pushing towards the Hawaiian Islands and impacting there. That was on Wednesday or so. Then things settled down for a little bit. Another gale tried to develop up over the North Dateline region on Friday. This was just like 2 days ago, but really nothing is expected from that. And then here we get into Saturday. A tiny gale developed just east of the dateline with 28-foot seas. This is going to get a little interesting, and this one behind it off Japan a little bit interesting too. But that's where we are as of current time. You see the first gale starting to build in coverage with seas at 25 feet, and the system pushing off Japan kind of diffused, trying to get its act together. But you already see swell energy pushing towards the Hawaiian Islands and certainly the U.S. West Coast. Hooray, swell is finally on the way for California. And then over the past week in the South Pacific, given the time of year, one would expect nothing. We're looking for 26-foot seas or better. Don't expect to see it here. I've been kind of monitoring, but no, nothing happening. So no swell from the south is expected for the coming week. To the North Atlantic, if you've been following any of the feeds, the YouTube shorts and Instagram feeds, there's been a lot of activity over towards Portugal and Ireland. Let's see what we see for the past week here. A little gale there with 30-foot seas. That was last Sunday. That system is come and gone. Another system developed with 36-foot seas there on Tuesday, falling directly towards Portugal on Wednesday with still 32-foot seas, making a direct impact there and into the Bay of Biscay. Another system behind that, you can see that's just kind of this steady pattern. This is what should be happening in the Pacific, but it appears to be focused on the Atlantic for the moment. A fragmented area of 32 or 33-foot seas. On Friday, we had up to 38-foot seas pushing right into the Bay of Biscay. Probably a pretty blowy mess, and you also see seas pushing down into Portugal. Seas up to 35 feet Friday night, and then impacting directly there south of that area. And we're into Sunday, current time, new gale building off of Newfoundland, trying to get organized. To the South Atlantic, running through here again, looking for 24, 26, 28-foot seas, 30-foot seas on Tuesday night, Wednesday morning. That had to be 6 a.m. Wednesday in South Africa. Built some swell. You see the swell front there pushing into the coast as of Thursday. See if anything developed behind that. We're into Saturday and now Sunday current time, and it looks like not. So whatever swell has happened is pretty much over with. And then finally down to the Indian Ocean. I'm actually going to go back a little bit. Here you go. You see this gale that developed on Friday night into Saturday with 43-foot seas lifting northeast. That northeast push is what you want. That really helps push the swell off to the northeast. You see the swell front on, well, pushing into Western Australia about midday Monday, and then working its way up in towards the Mentawai Islands. Another gale developed or is developed behind that. This was on Tuesday and Wednesday. Nothing particular there, but you see some swell pushed into Western Australia as well. And yet another gale on Friday developed with 40-foot seas lifting northeast. Again, that preferred track into Saturday. And as of Sunday, you see the swell front now just starting to push into the Western Australia coast and again bound into the Mentawai Islands and Indonesia. So what does the future hold for? We're going to zoom in here on the North Pacific, our main forecast area. And we're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. And when those gales form, the jet stream helps direct their track. We're looking for a trough, a push in the jet to the south. We see that right here. What that helps do is create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure in the northern hemisphere. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, imparting energy to the ocean, creating seas. As those seas radiate away from the fetch area, the lesser period elements decay away, exposing longer period swell, and swell and hit your beach like in Hawaii there or California there. That produces surf. So we have a consolidated jet stream flow pushing off Japan, reaching much further off to the east than it has for the past couple of weeks, to a point generally north of Hawaii. I'll even give it to 150 west. Winds up to 180 knots in a small pocket. This being fed by energy way down here in the West Pacific, right on the equator. What I call the Kelvin wave generation area, this area right in here, from the entrance to the West Pacific, starting about 125 east on over to about 170 west. When you have westerly wind anomalies, we're going to get into this in a minute, that basically helps feed energy to the jet stream, and that's exactly what we have in a stronger jet. Much better for making surf. All right, so the jet is consolidated, pushing to a point roughly north of Hawaii, but then kind of fragmented in a mess east of there. In general, a ridge is in control over this area, weak high pressure, not doing anything for swell production. Let's put this into motion, see what's forecast. As we get into, you can see it right off the bat. The jet pushing further off to the east. We're into Monday, and it's almost to 140. You see the jet splitting here. There's your split. In between the split jet, you get the opposite. You get high pressure, not low pressure. But also notice trough here in the Gulf, trough over just west of the dateline. Those same two systems that we saw earlier on the wave model charts will be fed by this pattern. That continues into Tuesday. Now the main kind of low here, the trough sort of flattens out, but the other trough pushes up into the Pacific Northwest on Tuesday into Wednesday. Jet makes it to about 135 west, which would be maybe 700 miles off of San Francisco, something like that, maybe 800 miles. Let's see, it actually looks like it's trying to push further in, but you also get the sense the split is trying to redevelop. Winds, 190 knots in a pocket or two, but mainly 180 knots. Jet, very consolidated. I mean, this looks like a great flow. We just need a little bit more of a trophy pattern. You see, as even into Friday the 30th, of January. Little trough here off the Kuril Islands, another in the Gulf of Alaska. There we go, getting better defined as we get into Saturday. Another trough. I mean, this is actually a great pattern for supporting gale development. And then here come the winds, 190 knots as we get a week out, building to almost 200 knots on Sunday. Solid 200 knots. The jet probably will push even further off to the east, but big trough forecast digging out here in the Gulf of Alaska. A great pattern, it looks like, for supporting gale development and into the Gulf of Alaska, something we've needed. The whole pattern has been focused in the far West Pacific. Now it looks like the Gulf of Alaska is finally going to come into play. So what effect does that have down lower in the atmosphere at the ocean surface? Surface level pressure and surface level winds. We have one low pressure with 40 knot winds targeting Hawaii as we speak, 18Z on Sunday. Another gale winding up off the Kuril Islands or Japan, it with 35 to 40 knot winds, but sort of one fetch area there, one fetch area there targeting the Hawaiian Islands. Put this into motion on Monday. They both proceed off to the east. The first fetch losing energy, 35 knot winds. The second one, broader in coverage, but not as concentrated. And then we continue with the same patterns, almost like one long continuous fetch with a core at 45 knots as we get into Tuesday. This will target the Hawaiian Islands really well. But then all this fetch, 30 knots, 25, 30 knots, all targeting, I'll say, from Point Conception northward with sideband energy down into Southern California. That pattern continues as we get into Tuesday night. Then things weaken a little bit as we get into Wednesday. Still consistent 30-knot winds at times. Thursday into, now we're into Friday, things settle down, but then it looks like, here we go, another smaller gale trying to develop on Saturday, just west of the date line, lifting northeast, getting better organized with 40 knot to 45 knot winds, again targeting Hawaii and the U.S. West Coast. There we go, 40 knot winds, solid on Sunday night, a week from now. Again, targeting the U.S. West Coast. Look at the high pressure right there, just barely hanging on, protecting California from probably much needed precipitation, but doing well for producing surf. So what effect will those winds have on the ocean surface? Well, as of right now, we know we have 25-foot seas in the northwestern Gulf targeting the U.S. West Coast with sideband energy at Hawaii, and another area of 23-foot seas developing off Japan, both moving off to the east. Seas build later tonight to 30 feet. Do we get any higher than that? Nope, right at 30.5 feet, targeting, again, the same locations. The second gale trying to organize behind that. 28-foot seas continue into Monday, falling southeast. Some energy likely for Southern California. So you get into Tuesday morning, 22, 24, 26, maybe almost 27-foot seas targeting the U.S. West Coast. Seas to 32 feet behind that. I mean, this is kind of a good pattern. 26, 27-foot seas pushing up off the Pacific Northwest as we get into Wednesday. 28-foot seas pushing over the date line, targeting Hawaii and the U.S. West Coast. So we get into Thursday. Secondary fetch continues with 26-foot seas closer to the Hawaiian Islands and targeting the U.S. West Coast. And then all that takes a little bit of a break. Another gale builds behind that on the date line on Saturday. Tiny area, 30-foot seas. You really want a broader coverage. And rebuilding to 30, I'll say, 33 feet a week out on Sunday. All aimed off to the east. Energy you see pushing towards the Hawaiian Islands and the U.S. West Coast 180 hours out. Down to the southern hemisphere, no expectation of anything developing here, but we'll take a look just the same. You never know. Looking at 20-foot seas, we need at least 26-foot seas over a pretty good size area, and nothing forecast for the next week. Continuing on. To the North Atlantic, here is our system developing quickly as we get into Sunday evening, actually about, a couple hours from now. 44.8-foot seas forecast, continuing to 45 feet, 43 feet. You can see where they're targeting. It's really here. It looks like Portugal and Morocco. Aimed well there, but getting perilously close to the coast and into the Bay of Biscay for that matter. By Tuesday night into Wednesday, you can see 28-foot seas directly impacting the coast of Portugal. Another system developing behind that. Another system even up here, but notice everything aimed off to the east, not at Ireland for the moment. The next system builds with 42-foot seas into the continuing 42 feet. Again, Portugal, Bay of Biscay is the main target, and Morocco's secondary energy, with secondary energy continuing there into 28 feet into Friday night. And yet another system develops smaller, lifting more to the northeast. Maybe some hope here for Ireland as we get into Sunday, February 1st, and you see swell energy, not as the gale not as defined, not as consolidated, but still pushing energy up into northern UK and Ireland. To the South Atlantic, we'll put this in motion. Expectations are low on anything developing, but here we go as we get into Thursday, 29th of January, small area 28-foot seas, down into the 27-foot range, 28-foot, 30 feet. Aim pretty well towards South Africa. Swell possible pushing into the coast nearly a week from now, late Saturday and early Sunday, with another system, small, falling apart behind that. And then finally, the Indian Ocean gale fading off the western coast of Australia, producing swell that is impacting the coast as we speak. You can see it radiating up into Indonesia, expected to arrive into midday Tuesday, something like that. Then we start looking for some new source of swell activity. We're out to Friday the 30th of January, Saturday, and let's see, we got till about Sunday here, and really nothing behind that. So take what you can get while you have it. The local wind forecast for California right here and Hawaii. Southern California here, there's the Baja border. Point Conception, Monterey Bay, San Francisco Bay, up to Cape Mendocino and the Oregon, California border there. High pressure, weak high pressure, light wind regime in control for the moment. Hawaii under light southeast winds. So we get into Monday, south wind pattern starts building, low pressure building over the Gulf of Alaska. Cold front out here starts pushing south winds up the California coast, probably southeast near shore, and some sort of a front with a northeast wind pattern approaching the Hawaiian Islands, pushing over the Hawaiian Islands but dissipating quickly. Front pushes close to California Monday night. Into Tuesday, starts grazing the extreme North California coast. South winds down into probably Monterey Bay or so, maybe even south of there, but not something significant. Some sort of a southeast wind regime for the Hawaiian Islands. On Wednesday, same sort of deal. Here comes high pressure trying to lock down California again. The jet splitting out somewhere right around here. So the jet coming in like this, splitting up like this, taking the storm track north with it. Hawaiian Islands, some sort of a light wind regime, 10 knots. Northwest winds on Wednesday night into Thursday, 10 knots and maybe 15 knots. This is first thing in the morning south of Monterey Bay. Not getting, no real gradient forming, some sort of probably light wind regime right in the northern central California region. Some sort of a south to southwest flow for the Hawaiian Islands. Friday, pretty much a repeat of the same. Saturday, light wind regime. Again, the fronts just cannot push in through the high pressure because the jet stream is split. Trades 10 knots for the Hawaiian Islands, and then we get into Sunday a week out. Pretty much more the same, at least for the immediate future. Rain and snow forecast for California right here. You kind of probably already guessed how this is going to play out if high pressure is locking down most of the state. Here we go. Rain into Cape Mendocino Tuesday night, making it down to about Bodega Bay, and then quickly evaporating. Is there anything else behind that? You see just this perpetual front off the coast, but it just cannot make any headway as long as the jet stream is not having enough energy to push it fully into the coast. We're into Sunday, a little bit of rain again for Cape Mendocino Sunday night, but no snow for the Sierra, no rain south of Bodega Bay, high and dry. The snow forecast dashboard for the Olympic Valley, Palisades, Tahoe, formerly Squaw Valley, literally no snow forecast. We're not even going to go look at any other locations. The snow level forecast. Red, if there was precipitation, this is above freezing temperatures. The gray would be sleet if there were precip. The 32-degree line right where the gray and the white intersect. And then blue is 28 degrees. So you see snow levels today, 7,000 feet, building to 8,000 feet on the 28th. Up to, at one point there for a moment, 12,000 feet early on the 30th, and then settling back down somewhere in about the 9,000 foot range. This is the top of Palisades Tahoe at 9,000 feet. This is the base parking lot over on the Olympic Valley side at 6,200 feet. So you see basically the snow level or the freeze line well up the mountain and above or at the summit pretty much the whole of the forecast period. The Surf Forecast dashboard for a couple of select locations. Start up in the Pacific Northwest, the Columbia River area, again, right there at the intersection of Washington and the Oregon border. Really no surf forecast until you get into Wednesday later in the day, and the first swell hits, goes right from, 2.2 feet to 20.2 feet in a period of 3 hours. That's probably a little bit overstated. It's probably a slow build, but you get the general idea. But also with south winds in the 20-plus knot range. That swell slowly starts to fade as we get into Thursday, still in the 13, we'll say 11 feet and above range, continuing into Friday. Then we get into next weekend, surf in the 8-foot range and up to 12 feet on Sunday. Notice offshore winds there, so some potential. Let's take a look at swell size. Peak swell size, 13 feet at 15.5 seconds. Late Wednesday into early Thursday. Again, 13 feet at 14 seconds on Thursday. 10 feet at 12 seconds on Friday. Dropping off some. Period comes back up. Swell builds to 8 feet at 15 seconds on early Sunday and then dropping from there. Down to Ocean Beach, San Francisco. No meaningful swell forecast till you get into Wednesday, and then things bump up a little bit in the head-high range, and then build dramatically from there up to 14.5 feet. That might be a little on the high side, maybe more like 13 feet, but you get it with northwest winds at 8 knots or so. Swell slowly fading Friday down to 7 feet later on Friday, 5 to 6 feet on Saturday, and back up to 10 feet on Sunday with some flavor of north-northwest winds the entire time. Swell heights building to 9.5 feet at 15 seconds on Thursday, dropping from there 5.5 feet on Friday at 12 to 13 seconds, 5.5 feet 11 seconds on Saturday. So it goes through the whole profile from 16 seconds the whole way down to 10 seconds on late Saturday, and then up again at 7 feet at 14.5 seconds on Sunday. Some amount of this swell will also work its way into Southern California, now not, below the critical north threshold, but pretty close. So really nothing going on. You see the swell start to build on Thursday, up to 5 feet surf heights. This would be Thursday night, Friday. So the main event's probably Friday during the day. Swell at about 4.5 feet. Dropping from there, 2.5 feet through the weekend and continuing. Winds not too bad. Swell heights building to 3 feet at 15 or 3.2 feet at 15.5 seconds. Dropping down from there. 16-second energy you see showing up the last bar here on Sunday at about 1.9 feet. To the north shore of Oahu, now not as directly on the swell track as Northern California, but closer to the source. Net result, sort of a wash. You get 10-foot surf. Okay, we'll take it with some sort of a south-southwest flow at 5 knots. This is on late Tuesday, early Wednesday. Swell starts dropping Wednesday. Next pulse of energy in, surf in the 10-foot range with basically no wind. On Friday, Saturday, surf back up to 12 feet early in the morning, fading from there with trades in the relatively light wind speed pattern. Swell heights, Tuesday, 7 feet at 14 seconds late afternoon. Wednesday dropping from 6 at 14. Thursday dropping, but then rebuilding again up to 7 feet at 14.5 seconds early Friday morning. Saturday, again, new swell, 7.5 feet at 14 seconds, and then fading from there. To the central coast of Ireland, surf heights as we get into Tuesday, 18 feet, maybe building to 25 feet on Wednesday. You look at the wind speeds, though, just nuking wind, 30 knots. That swell fading. Another pulse of energy in on Friday. Surf heights 29 feet, south winds 20 plus knots, and then 25 feet again on Saturday, fading into Sunday. Swell heights up to... Okay, that's probably a little bit of a minority report. 17.9 feet at 16 seconds, but certainly 16 feet at 16 seconds. Prior to that, 12 feet at 15 seconds. You get the idea. 17.5 feet at 16 seconds. We're out into Saturday, 18 feet at 14 seconds. Swell is not an issue. And then finally, to central Portugal, surf heights, just like background swell, 15 feet with some flavor of southwest winds at 30 knots as we get into Monday. Tuesday, 27-foot surf. Again, this sort of west wind pattern, up to 44 feet. Wednesday, later in the day, west winds still in the 15-knot range. That starts fading out. Another pulse in on late Friday, 34 feet with some sort of west winds at 25 knots. So when the wind finally dies down, so does the surf. Let's go take a look at swell heights just for fun. We'll start on Tuesday morning, 18 feet at 12 to 14 seconds. Building to 26 feet at 17 seconds on Wednesday. That slowly works its way down both size-wise and period-wise. Next pulse comes in 18.5 feet at 17 seconds on Friday, and that slowly starts fading down. Certainly no shortage of swell. All right, let's go take a look long-term. Let's examine the two major weather oscillations that affect our weather over the long haul. That is anywhere from 2 weeks out to 2 or 3 months out, if not a year out. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by discussing the MJO, the Madden-Julian Oscillation. There are two phases, the active phase and the inactive phase. They rotated around the planet west to east. The active phase on one side of the planet, inactive phase on the other. Again, rotating west to east around the planet. The active phase on one side of the planet, the inactive phase on the other. The active phase is our friend. It is a low-pressure system. It literally takes warm, moist air at the ocean's surface, lifts it up into the atmosphere. That warm, moist air eventually gets sucked up into the jet stream, making the jet stream stronger. A stronger jet stream pulls the jet stream together, consolidates it, makes it more efficient at digging out troughs and therefore producing surf. The inactive phase of the jet stream does the exact opposite. It is a high-pressure system. It is falling air, dry air, cuts off the flow of energy to the jet stream, making the jet stream weak and split. So based on the jet stream models we saw just a bit ago, one can assume that the jet stream is consolidated and pretty strong. Therefore, the active phase of the MJO is somewhere over the West Pacific doing its magic. One would also then surmise, though, looking at just the storm pattern in the Atlantic Ocean, that maybe some sort of the active phase of the MJO is there, or for whatever reason, because the jet stream is so strong pushing into, at least over the Pacific, that maybe some degree of it is reorganizing, pushing off the U.S. East Coast. It's kind of hard to tell, right? You know, it seems like there's two active phases in play at the same time, but they're not. Anyway, the active phase, because it is a low-pressure system, trades are generated by a high-pressure system. The active phase, because it's a low-pressure system, negates the effects of the high pressure, making trade winds weaker than normal or out and out reversing trade winds. Trade winds typically blow from east to the west. Okay, the inactive phase of the MJO does the exact same thing, opposite thing. It is a high pressure system. It marries up with the base level high pressure systems in our oceans, making trade stronger than normal. So we're looking at this chart, trying to tease out where the active phase of the MJO and what is going on based on trade winds. This is data from the TAO buoy array, a series of buoys strung across the equator. This is the East Pacific here, West Pacific here. Here is the equator. We're We're just looking at the arrows, and they tell us how strong, 5-day average, what the trade winds are doing. From the east, pretty strong over the East Pacific. Oh, I'm sorry, there's the date line right there. This is the far West Pacific. That's New Guinea there. And on the equator, well, Ecuador is off the edge of the picture here, somewhere around 80 west, so over here. Anyway, trades moderately strong over the East Pacific, moderately strong over the Central Pacific, getting pretty strong over the date line and into the Kelvin wave generation area. The West Pacific, from as far west as you can get, like 125 east, to about the day, a little bit over the date line, 170 west. So in this area, trades have actually, it looks like they're building, and it does not look like the active phase of the MJO is in play, at least according to this. But anomalies is what really matters. It's not the actual wind speed, it's the difference from normal for this time of year. That tells us whether the trades are blowing stronger than normal for this time of year. Far West, East Pacific, well, there's really no arrows, so trades are pretty much neutral. In the Central Pacific, same sort of deal, kind of a neutral pattern. Maybe a little bit of westerly anomalies here right on the date line. Trades a hair bit weaker, but then kind of rebuilding. The interesting thing is trades have been nuking out of the west. That would be trades much weaker, if not full-on reversing direction, westerly wind burst for a couple of weeks now. We're going to see that here in a couple of charts coming up. So for the moment, it appears there is a bit of a break in MJO activity, active phase MJO activity over the West Pacific. Let's dig deeper. Here's the Hindcast for 5-day or for zonal wind anomalies for the entire planet. South America, Central America, New Guinea right there, 0, that's the equator. Date line right there, so there is India, there's Africa there. The oranges and reds, westerly anomalies. Look at this giant area of westerly winds. This was on the 19th of January, so what, 6 days ago? Pushing into the West Pacific. Clearly a sign of the active phase of the MJO, again on the 20th, 21st, 22nd, though you see they're losing a little bit and losing a little bit on the 23rd. So active phase of the MJO, I mean, this qualifies as a full-on westerly wind burst. These are the precursors to El Nino. When the MJO gets strong, it pulses and you get success. And the MJO being active typically takes anywhere from 4 to 6 weeks to make it from here over to here to cross the Pacific. And we've had a pretty good run of westerly anomalies. In fact, this is the second westerly wind burst so far this winter. There was another one, I think it was in like late November and December, or in late November, we had a break. Now here comes the next one in January, and now it looks like maybe a break is starting to set up. Let's dig a little deeper. So here's where things get interesting. Outgoing long wave radiation prediction of the MJO related anomalies. All that means is more sunlight bouncing off the ocean surface. The sun hits our atmosphere, goes down to the ocean, bounces off the ocean surface. If you get more reflectivity back, that means there's less clouds, okay? Less clouds would be the inactive phase of the MJO, high pressure. The oranges and the reds, more sun, higher numbers here. You see that's more radiation bouncing, sunlight radiation bouncing off the ocean surface. And again, South America, Central America, New Guinea, EQ is the equator, date line right there. And it's only 5 degrees north and south of the equator that matters. It's amazing, but just that little 10-degree wide strip across the Pacific can really have a significant influence on weather around the entire planet. So according to this active phase of the MJO, the blues, that would be negative anomalies, less sunlight bouncing off the ocean surface. So active phase here, inactive phase building over the maritime continent. 5 days from now, active phase fading over the date line, inactive phase making it into the West Pacific. 10 days from now, inactive phase in control and building to strong status. 15 days from now, 2 weeks. That's per the statistic model. The dynamic model, though, paints a much different picture with active phase fading a little bit 10 days out, and then rebuilding 15 days from now, with the inactive phase remaining sequestered somewhere in the Indian Ocean. All right, and then to the GFS model, a dynamic model going out 2 weeks. The forecast down below here, right here, 850 millibar zonal wind anomalies. That's the winds up about 4,700 feet, but a good proxy for what's going on at the surface. This is the zonal wind anomalies for the entire planet. So the date line runs right up the middle of the chart. All we care about is the West Pacific from 125 east to 170 west. So right there. So here was our last westerly wind burst active phase of the MJO. Started January 5th and went through pretty much today, is fading, if you will, at this very moment. And just today, or maybe it was yesterday, all of a sudden the GFS model started again teasing about, looks exactly like what happened when this guy started back in early January. Westerly wind burst. Again, notice with no real, there's a hint of an inactive phase, easterly anomalies, but westerly anomalies holding over the entire West Pacific the entire time. This is kind of a big deal if it develops as forecast. Now, I am sure the GFS model is grossly overhyping the strength of this if it happens at all. You notice the previous charts, the statistic model said, no, we're going into a full-on inactive phase of the MJO. GFS model says, I don't buy it, at least for now. We'll see what the model says tomorrow. This is out, it says, well, 7 days from now. That's 7 days from now. Okay, 8 days from now. The active phase of the MJO returns. It's kind of a big deal. And remember, we had an active phase with a westerly wind burst back in November, another one in January, and then maybe another in February. This is typically how El Nino forms. I'm not saying we're going into El Nino. This is a forecast. I don't believe it going out this far, but it is a very interesting thought that the GFS model would even consider that such a thing might happen. So keep that in the back of your mind. And now the CFS model, another dynamic model, long-term model. Again, the reds, westerly anomalies, blues, easterly anomalies. The MJO is delineated with a black contour, solid, like here. That's the active phase of the MJO. So this is our active phase with our supposed westerly wind burst, which really wasn't a whole lot, but it actually did set warm water in motion in the West Pacific. An inactive phase through the whole month of December with easterly anomalies. Here's our current active phase that's set up starting in right around Christmas time, peaking about 2 days ago, 3 days ago, over the far West Pacific, and is expected to continue, according to this, for another almost 2 weeks. Now, this model doesn't show another active phase, and it doesn't show another westerly wind burst. But again, this is on January 24th. That GFS model was a day earlier, or a day, more current, January 25th. So we'll see if this guy wakes up and picks up on that. It's actually showing a weak inactive phase setting up later in the month of February with easterly anomalies on the date line. And then finally, the CFS model going out 3 months. Past performance down here, the forecast up here. So here was your November, the solid contour. Oh, actually, let me take this out. Let's look at it this way. So here was the solid contour, the westerly wind burst in November. Not particularly a big deal. Far West Pacific starts right here, 125 east, so right there. And you see most of the westerly anomalies were barely even in the Pacific at all. Here's our current westerly wind burst, much stronger, and notice westerly anomalies made it the whole way to the date line and are forecast to continue for another 2 weeks. And then you get further out here and see westerly anomalies are forecast continuously, not building, but solid over just west of the date line and then building to the date line as we get into March and April. To me, this suggests that a building pattern, we've had a very, very slow start surf-wise to in the Pacific Ocean, but this suggests that pattern, with this energy pushing further across the date line, should build the jet stream, push it further into California. Stronger storm pattern as we get into, I'll say, March and April, maybe a late winter rain and or early spring, late winter rain and snow season, possibly. The other interesting part here, right here, easterly anomalies. You see, you don't really see that here back at 60 east, but all of a sudden, as the westerly anomalies start building over the dateline, easterly anomalies start building over the maritime continent. This is a classic pressure switch. Where you see where you had all your blues here on the dateline, all of a sudden they set up over the maritime continent. The westerly anomalies moved from the maritime continent over the Pacific. And voila, you have some flavor of El Nino, exactly what you want. Let's overlay the MJO here. All right, there was one active phase of the MJO. Here's our current active phase of the MJO with westerly anomalies forecast continuing for the next 2.5 weeks, a week in active phase, and another some flavor of active phase in late February into March, and then just kind of a mixed pattern. But again, the westerly anomalies, and this model has been saying it for, since September, I think, something like that. Let's overlay the low pass filter, the high pressure, low pressure bias. All right. The solid contour, low pressure. It was over the maritime continent. The dotted contour, the high pressure bias with 2 contours over the dateline. And notice just today, January 25th, second contour died. Notice the high pressure bias from here on starting to ease off to the east and then collapsing to the east as we get into March and April, with the low pressure bias inching slowly into the West Pacific, and then somewhere around the first week of March, earnestly making a big shove to the east with a second contour developing. Again, all this hints at some flavor of La Nina. Of course, you got to believe a model going out, in this case, 2 months, but the model has been consistently saying that, and the reality is what we're seeing in the Pacific is not exactly what the model said, but moving in that direction and steady every day. And then let's go talk about what's going on in the ocean, not at the ocean surface, but subsurface, down about 150 meters across the entire equatorial Pacific. This is data, again, from the TAO buoy arrays, those buoys that are strung on the equator from the East Pacific to the West Pacific. The little dots here, the X's, these are the anchor lines on those buoys. X's are sensors on those anchor lines. They give us subsurface water temperature, and then you use a model to fill in the gaps. We're looking for movement of warm water from the West Pacific to the East Pacific. Why does that matter? Well, El Nino is the switch of normal upwelling off of Ecuador and cooler waters to a warmer water regime. How do you get there? Well, it isn't just the sun baking the ocean surface. It is what they call a Kelvin wave. Warm water moving from the West Pacific to the East Pacific down 150 meters the whole way across the Pacific Ocean. All right, so we look at these contours and see if there's any movement, see if there's any sense that water is moving. So we have the 30-degree isotherm, which is back on the charts, moving to 65 east. As of today, the 29-degree isotherm has moved from 171 to about 173 east. 28-degree isotherm for today, holding exactly where it was last week. 24-degree isotherm, though, it was rising to the surface here at 125 west, but is now steady the whole way into Ecuador. But again, it is not the average water temperatures. It is the anomalies, difference from normal for this time of year. And what do we see? A giant tongue of warmer than normal water, 3 degrees, 2 degrees, working the whole way across the Pacific and starting to surface somewhere around 100 west. This is, in fact, the first Kelvin wave that was generated by the active phase of the MJO and associated westerly anomalies back in November. We have another westerly wind burst that just happened a week, 2 weeks ago. That will take 3 to 4 months to make its way across the Pacific. And then if you believe the GFS model, maybe another happening starting a week and a half from now. We'll see. The jury's still out on whether that's going to happen, but we'll see. Now, here's the same data amplified with satellite data. We'll get into that in a second. But you see clearly in the West Pacific, East Pacific here, here's your Kelvin wave that is pushed the whole way across the Pacific, reaching the ocean surface between 100 west and 120 west. You go, okay, great. Where's my jet stream? Where's all my storms? Now, let's be clear. It's going to take months, specifically 3 months of warm water gurgling up off of Ecuador before the atmosphere above that will even start to respond. So we're talking January to February to March, sometime in April, maybe the atmosphere is going to go, oh, I see, things are changing. Okay, because you have warmer water in the East Pacific, that supports more evaporation then starts creating rising air over the East Pacific. That in turn creates lower pressure over there. And then all of a sudden that lower pressure and the rising air has to go somewhere. You know what it's going to do? It's going to go fall over the maritime or even the Indian Ocean. They call it the Walker circulation. And you can go look that up on Google, but you get the general idea. This is the machine that can change the Walker circulation. So right now, Kelvin wave also indicated here pushing across the subsurface Equatorial Pacific. Sea level anomalies for January 18th is updated. It says every 5 days, but you can see that it takes a while for a satellite to wrap around the planet enough times to get a total mapping of the ocean surface. So about every 5 days you get an update, though there are incremental updates. Anyway, all right, Chile, Peru, Ecuador, Galapagos Islands, Equator right there, international date line right there, New Guinea right there, Central America. All right, the oranges, and we're only talking 5 degrees north and 5 degrees south. The oranges, yellows, whatever you want to call them, are not the temperatures, but the height of the ocean surface. The satellite measures the ocean surface height. It knows what is normal, the normal sphere of the ocean. If ocean heights are higher than normal, that means warm water is at depth, because warm water expands. When it expands, it displaces the sphere of the ocean up above it. Likewise, colder than normal water contracts. When it does that, you end up with a divot on the ocean surface. Now, what we've seen, and you can literally see right here, a little finger of warm water. Again, it's only 5 degrees north and south of the equator. Pushing off to the east, a couple little pockets here. But you see, last week, a lot of this was all negative anomalies, -5, -10. All of a sudden, that's all gone. And there's a clear path. Again, that 5-degree path north and south. And that's indicating it's not a path open. It's literally warm water has created and pushed a hole into to the Galapagos Islands, almost Ecuador. And at some point, I would expect to see building. These yellows start to build in this area as more warm water starts building at depth in that area, ready to erupt to the ocean surface. Upper ocean heat anomalies over time. This just paints the same picture, but a little bit differently. West Pacific here, East Pacific here. Last year, cold water in the east. This was last winter's Modoki La Nina. Warm water buildup in the west. Why is that? Well, trades are stronger than normal, just scraping the ocean surface, pushing all the warm water in the west, while you had massive upwelling off of Ecuador. Then we got into last summer. Trades died. Warm water almost started building. And then we got disappointed in July with the return of the weakest of weak La Ninas, with 1, 2, 3 inactive phases of the MJO. But then here in November, here was our first push of the active phase of the MJO, and it set warm water in motion. December, another active phase, more warm water. The first leading edge of that Kelvin wave today is at, I'll call it 98 west, almost the whole way across the Pacific, ready to erupt. I think it's going to erupt more over the Galapagos Islands than in at Ecuador. The stronger the winds that blow in the west, the faster the Kelvin wave moves, and theoretically, the more warm water is embedded in it and the more momentum it has. This first one was a pretty weak westerly wind burst. I didn't even think it was real, but apparently it was. And it had a lot of headway it had to fight against a bunch of cold water in front of it. But it has arrived, and that is good news. Then we go to the ocean surface. At some point, that warm water, the subsurface, that Kelvin wave is going to erupt. Now, what is really interesting, that has not happened yet. But okay, let's get oriented. South America, Central America, New Guinea, equator right there, date line right there. But what we are seeing is the extent, the blues are colder than normal water temperatures, the reds or the yellows and oranges warmer than normal, again, limited to 5 degrees north and south of the equator. This cool water was at one point the whole way from Ecuador out over the edge of the date line. In the past week, it has pretty much disappeared in the East Pacific. It has disappeared in the West Pacific, and the dark blues inside this area bounded where, you know, the easterly anomalies and the upwelling is happening have significantly gotten weaker and are warming. Here's the 7-day trend. Now, you notice a little bit of upwelling is just like today starting to happen. But this broad area of warming off of Chile, Peru, almost up into Ecuador, and all south of the equator too. And the whole way out here over the date line, again, indicates, or at least is indicative of, the warming trend that's occurring over the equatorial Pacific. Even this super conservative sea surface temperature anomaly difference using the global mean temperature versus some other way suggests warming. The aerial coverage of the cool waters is shrinking, not as dramatically and not as much, but it only reaching to the date line now. So even this chart is showing some sort of warming pattern is occurring. Here is just raw data, the sea surface temperature anomaly index for the Nino 1.2 region. This is the area right there by Ecuador and the Galapagos right on the equator. Temperatures for the past week and a half hovering right at barely neutral, 95 thousandths of a degree below normal. Now, neutral is half a degree above to half a degree below. So just considered neutral. We would need to be way up in here before any sort of an El Nino, you know, would start becoming apparent. But at least we're in the neutral territory. And then we go to the Nino 3.4 index. This is the official El Nino monitoring region from a point south of California out to about the date line, 5 degrees north south of the equator. There we are, 929 thousandths of a degree below normal. From half below to half above is neutral. From half below to 1 below is considered weak La Nina. We are there. This will probably be, though, the last indicator. Well, actually, this will be the last indicator that's really going to change. And remember, there's a Kelvin wave subsurface. This is surface temperatures, not subsurface. So subsurface-wise, we know a whole bunch of warm water is coming, and we know that there have been 2 westerly wind bursts, and if the GFS model is right, maybe a third, going to pump yet more warm water from literally the shallow warm waters of the maritime continent into the West Pacific and then across the entire Pacific. So no real reaction here yet, but we will see this change at some point. The Southern Oscillation Index. This is an indicator of what's going on in the atmosphere above the ocean. All right, now let's put things in perspective. The ocean on the equator has been cooler than normal for months now, okay? If you have cooler than normal water, it doesn't support evaporation. It supports high pressure. So, you know, you wouldn't expect a whole lot going on in the atmosphere. The only exception would be if the active phase of the MJO is in control, you know, in its 2 or 3 week journey as it plods across the equatorial Pacific. This is the difference in pressure between Darwin, Australia, in the Indian Ocean maritime continent, and Tahiti in the central Pacific. When the active phase of the MJO, low pressure, is pushing over the central Pacific, Tahiti here will pick up on it, and this index will go negative. Sure enough, minus 14.36. Now, Tahiti is at 140 west, so it's a pretty good ways across the Pacific. It is not in the far west Pacific. So this is kind of a lagging indicator, but you see for the past 1, 2, 3, 4 days, pressure is dropping, indicative of the active phase of the MJO that's been going on in the West Pacific since January is finally making it to the East Pacific. Before that, oh, yeah, so we're at minus 14.36. Where were we a month ago? Plus 14.69. So from the inactive phase to the active phase. The 30-day average SOI takes some of the noise out of this. 8.25. Where were we a month ago? Minus 2.25. So pressure was rising, but we will see this dropping at some point. In fact, it's dropping a little bit from, what do we got, 10.76. And then the 90-day average, your El Nino, La Nina indicator. This is your MJO indicator with a 15-day lag time. This is your 90-day average with a 45-degree lag time for El Nino, La Nina. Today, plus 7.17. Where were we? Plus 7.91, so basically unchanged over the past month. Let's look at this data on a graph. It probably makes more sense that way. Here's a 30-day SOI average graphed out. Neutral is plus 7 to minus 7. There was our La Nina from last year, these peaks, high peaks here. The upward pushes are the inactive phase of the MJO. The downward pushes, the active phase. So we had a big inactive phase there in December, right? And then, boom, here was our, in November, where was this? Let's see, is the inactive phase, or the active phase, in November, early December. Then we just went through an inactive phase, and now another active phase is setting up on the charts. When the active phases, the downward pushes, are stronger and last longer than the inactive phases, you end up down here in the reds like that in El Nino. When your inactive phases are stronger than your active phases, you end up here in the blue in La Nina. Ocean surface currents, heavily affected by trade winds. Ecuador and the Galapagos and the equator. And you see the current moving from east to west driven by trades. This is updated, I think, every day or two. Okay, but in the far west Pacific, again, give that a second. Notice the current running through the islands here and then out north of New Guinea, the whole way across. Last week, the easterly winds here were blowing to 171, which is basically right there. Today, they've given up ground. A week later at 174 west. So suggesting west anomalies in this area, building a westerly current. And that's also what's driving all the warm water that's in here, dumping into the Pacific Ocean and making its way across the equatorial Pacific in the form of a Kelvin wave. The sea surface temperature forecast from the CFS version 2 model for the official El Nino monitoring region, the Nino 3.4 region. January 15th, right there. Literally any day now, we should be crossing over the threshold. A half a degree below to half a degree above is technically puts us in ENSO neutral. And then by late February, early March, fully neutral. As that Kelvin wave erupts in the far East Pacific and that warm water starts getting dragged by trades across the greater equatorial Pacific, temperatures will start rising. Now, do I think that we're going to have 1.7 degree above average temperatures in the Nino 3.4 region in October? No. I mean, that would be that'd be pushing us into near super El Nino status. You got to be up at 2. This is probably grossly overhyped, but it gives you an idea of at least the trend that we believe is coming. Again, with Kelvin waves, 2 in the bag already and maybe a third coming. And that's like a slow-moving train wreck. It's going to take a while for it to manifest itself in the atmosphere, but at some point, it is definitely going to have an impact. The consensus model of all possible El Nino models, dynamic models, you see them all listed here, statistic models all here. You can just literally look at the graph. There's the 0 degree line. The green, if I can get it, there it is. The statistic model average of that's where we are right now and what the forecast is. Half a degree above, half a degree below is normal. The dynamic model, there we go, suggests the weakest of weak El Nino conditions as we get into September, October, November, August, September, October. Let's go look at the data. All right. The Let's go. Here's the dynamic models. You can look at all the data. I'm just looking at the average here. It suggests we're going to be technically neutral by February. And then as we get into the beginnings of fall, 3/4 of a degree above normal. And this is across all the different dynamic models. So the statistic model's way more conservative, suggesting only 0.299 of a degree above neutral. So basically just dead neutral, versus a half degree difference almost between the two as we get into next fall. And then I don't even know, can we find the CFS? Oh, the CFS model doesn't even have data out there. So hard to say, but this is a much more nuanced and subtle view of the world. The CFS model in and of itself tends to be a little bit hair on fire type presentation, but still it's suggesting at least a movement in the right direction. So what does all this mean? Well, right now we finally have a jet stream that looks pretty good. It's being fed by the past active phases of the MJO and westerly anomalies that are persisting in the West Pacific. A stronger jet stream is better for keeping it consolidated, digging out troughs and making storms. It has not made it to the U.S. West Coast, which is actually a good thing if you want cleaner surf. That is exactly what we want. And the same for Hawaii. You don't want the jet pushing right over top of you. It just turns into a blown out mess. At some point we will need precipitation, but right now I'm a beggar and I'll just take surf. Give it to me any way I can get it. That pattern is to hold, if anything, building over the next week. Beyond that, kind of hard to say. Certainly no snow until you're up to like almost British Columbia sort of thing. But the long-term models is suggesting the jet stream inching closer to California, but still even 2 weeks out, not pushing into the coast. But if that westerly wind burst develops in the West Pacific as the GFS model is hinting at, then the jet stream will get supercharged. It'll get another dump of energy into it, and that maybe will push the jet into California. If nothing else, it'll certainly help the storm track for weeks to come. Looking longer term, yes, we're still in... Technically, I don't even think I'd call it La Nina anymore. But if it is La Nina, that's all going to be gone in the next couple of weeks. And we're going to be in full ENSO neutral, moving towards some flavor of warmer neutral and maybe something more. Looking longer term, fall of next year, things looking much better indeed. A stronger jet stream likely. Some flavor of El Nino-ish like pattern set up, which means a stronger jet stream which means more storms. And even if we don't get a lot of precipitation into California this winter, next winter we'll probably make up for it. And remember, we've had 3 years prior to this of good, healthy rainfall. All the reservoirs are in really good shape, so I'm not too worried about lack of rainfall, at least for the moment. All right, and looking beyond that, well, you make your guess. Let me know what you think of where we're going, but it seems like some flavor of El Nino is coming. If you enjoyed this video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down on the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, as many of our viewers have, we would certainly appreciate it. Just hit the super thanks button down below, the heart with a $sign with it. And with that, we are done for tonight. We'll do it again next week, same time, same channel. Thanks so much for watching and supporting this video series.